Hey, chemistry students. Hey, it's Thursday before Memorial Day. I'm hoping that you guys have some fun weekend plans and that you're starting to see more people. It's exciting that we don't have quite as many rules on us anymore. I hope that you guys get to connect with your friends and that you have a really good weekend. Hopefully the weather's nice. The other thing, we only have a few weeks left, so after this key, if you guys, have still have trouble, go ahead and post what you've got. Also on Saturday, I'll try and post up the full answer set to this worksheet and do your best. We've got probably 2 more weeks of studying, and then we'll take our final, which will be exam 7, in on that last week of school. And we'll try and do it early in the last week of school so that we can wrap things up. But Mr. England and I will talk about that more coming up. So let's start. I'm going to go through question 1. Okay, this is the molarity homework. So it says student dissolves 84.6 grams of potassium bromide. So you balance the charges K plus and Br minus, okay, in enough water to prepare 1.3 liters of solution. So what's the molarity? So I need to first convert grams to moles. So I'm going to divide by the molar mass. So you add up KBr, adds up to 119. And I've solved these in advance just so that I can write these out. So you'll see me looking over here. I'm just looking at my sheet. I'm going to carry extra sig figs, so 7.7109 moles KBr. And then to go from moles to molar, remember the definition of molarity is moles per liter. So I take the number of moles of the chemical and divide by the number of liters. And this one, since 1.30 only has 3 sig figs, I will write my final answer, 0.547 molar. Usually you put the chemical name after it so that you know what solution you're talking about. So 0.547 molar KBr. Number 2, I'm not going to do, but I'm just going to give you some hints. Here, magnesium nitrate, remember to balance the charge. So you probably have 2 nitrates. So make sure when you're adding up the molar mass, you account for 2 nitrates. Also, when I Wikipedia'd it came up with magnesium nitrate. Oops, I'm giving you the answer. Oops. Came up with magnesium nitrate, and it gave me the molar mass or the molecular weight. It said grams per mole. But it also gave me this one. Okay, and that's magnesium nitrate with 6 waters. So this is called a hydrate. So this was like our hydrated crystals that we've done things where we heated them in crucibles and drove off the water. A lot of salts come with water attached or embedded in the lattice structure. So it also gave me the molecular weight for that one, which was, well, much heavier, right? 6 waters heavier. So don't use this molecular weight if you're just solving a molarity problem, unless you know you're physically grabbing that crystal that is a hydrate, then you'll just use the anhydrous mass, which is just the magnesium and the nitrates, no water added. So use that molar mass. And the other thing, 375 milliliters, when you convert that to liters, it's 0.375 liters. So it's really similar to the question above, just you have to do a little more conversion. So hopefully that helps. And if I'm going too fast, just pause or rewind, but I don't want to make this video too long. So number 3, how many grams of HCl are in 60 milliliters of 0.443 molar hydrochloric acid? So using our definition, I'm going to plug in what they gave me. So I know the molarity is 0.443 molar. I don't know how many moles there are, but I do know it's 60 milliliters. So using my little trick, just move the decimal from milliliters to liters, move it 3 places to the left. I get 0.060. Okay, it started out as 60. I moved it 1, 2, 3. So now it's here. That's liters. So to solve for the number of moles, I'm going to multiply both sides of the odd equation by 0.06. So if I do that, that tells me x equals, and I get 0.02658 moles. Okay, And then it doesn't ask for how many moles of HCl. It asks for how many grams. So I need to convert from moles to grams. So 0.02658 moles times the molar mass. Hydrochloric acid weighs 36.46 grams per mole. So I'm just multiplying that by 36.46. I'm going to round to 3 sig figs because the starting gave me only 3 sig figs. So this one comes out to 969 grams HCl. Okay. Number 4, I'm going to give just a little hint because there's a video, I think one of those little short mini clip videos that I did talks about this, but again, start with your molarity equation, and it says how many milliliters are needed, okay, to contain a certain number of moles. So it gives you the molarity, and it gives you 1.5 moles, and it wants you to solve for the volume. Okay, so you're basically solving for this volume on the bottom. So algebra, okay, and just a little reminder, if you have something like 10 equals, let's say 2, let's do a bigger number, 50 over x. So you have something like that, and you're solving for x, right? You'd multiply both sides by x first and then divide by 10, but you could just do a little switcheroo. If you ever have x on the bottom of a fraction, you can say x equals 50 over 10, so I know x equals 5. So that's a quick way, right? The algebra will work out where the x and that 10 just swap places. So basically solve for the volume, and then once you've solved for the volume, convert to milliliters. There's 1,000 milliliters in every liter. Okay, number 5. Explain how you'd make a solution. There's a video, mini clip one on this one, but basically you need sodium thiosulfate. So sodium is Na plus, and thiosulfate is that guy. So again, you need 2 sodiums. So once you have the formula, you need 1.25 molar. Okay, you need 1 liter of it. So you're going to go from, I'm going to write this out, you're going to go from molar to moles. So solve out the molarity equation. Once you know moles, then you're going to convert to grams. Okay, and then the process to make a solution, you measure out the number of grams, you fill the container to the appropriate mark, which would be 1 liter in this case, then you dissolve it. You stir it to dissolve, okay, and that would be how to make a solution. Number 6. Number 6 is kind of an interesting one. This is kind of like how AP Chem structures a lot of their questions. They want you to draw and think through. These are called particle level representations. So they want you to draw little particles, even though we can't see them. They want you to visualize them. So here's a little practice for AP Chemistry if you want to take it in a couple years, which I'm hoping you do. And actually, hey, the AP Chem, even with distance learning, they just took their test last week. They really worked very hard at once the school closed, they studied for their test. They thought it went really well. So weird way to end the year, but they really enjoyed AP chemistry, and I'm looking forward to teaching it again in a couple years. Anyways, so it says calcium chloride. I'll just write out the formula. Calcium chloride is a 2-to-1 ratio, right? I have 2 chlorides for every 1 calcium. It says it's 2 molar, and it says that it's 5 liters of solution. So if I solve for that number of moles on top, I'd multiply both sides by 5. It turns out there's 10 moles of calcium chloride, so this is 10 moles of CaCl2. Now when those 10 moles break down, there's 1 calcium for every mole of calcium chloride. So there's going to be 10 calcium 2 pluses, so 10 of these. And then since there's double the amount of chloride, there's going to be 20 Cl minuses. So when you go to draw your representation, I'm not going to take the time to do it right now, but you would draw, right? I think the ones, it says solid circle is calcium. So I draw, right, 10 of those. I'm not going to draw them all out. And then I would draw 20 of the like open circles. And basically, there needs to be twice as many open circles or chlorides as there are calciums. So that's what a 5 molar solution would look like. If you had or sorry, 2 molar solution. If you had a 1 molar solution, it would be half as concentrated. So you'd have like five dots and 10 dots. And if you had half a molar, well, that would be 4 times less concentrated. So again, you'd just be cutting the number of dots down. Um, so that's what concentration stands for. Number 7, I gave Dylan a hint. So see Dylan's comments on the assignment. Okay, just to kind of keep moving forward. Um, you convert from like mill or well, you convert from percentage to a volume, and then volume to milliliters, and milliliters to grams. So see if you can work through that conversion, and then once you get it down to grams and then moles, then it becomes a molarity question. So just some extra conversion. Um, and oh, I guess if you're in Mr. England's class, you won't be able to see that. So, okay, I better just mention. So you take, if it's 20% ethanol by volume, and you know you have 1 liter, well, 20% of 1 liter is 0.2. So you have 0.2 liters of ethanol. Okay, then you go to milliliters, then you go to grams, and to do that you use the density. Once you're in grams, then you go to moles, which is the molar mass. And then once you're in moles, you go to molarity, which is moles divided by liters, right? So you divide by your volume. So hopefully that process works out. Again, 0.2 liters, do all that conversion to get to molarity. Okay, and then number 8, I'll do with you. It's some sodium hydroxide plus some hydrochloric acid. It says is neutralized. Well, when we neutralize things, we always end up with a salt or an ionic compound and water. And everything in here is 1-to-1, right? So it doesn't need any more balancing. So that's part A. Part B says calculate the number of moles of each. So if you rearrange the molarity equation, it turns out the number of moles is equal to the molarity times the volume. So I'm just going to take for each one, it gives me a molarity, so 0.2 molar, and this was NaOH, times the volume, and it says we used 100 milliliters, so that's 0.1 liters. So I multiply it, I have 0.2 moles NaOH, and I do the same kind of thing for HCl. This time it's a little less concentrated. So that comes out to 0.15 moles HCl. Okay, so that's how many moles I have in both of my solutions. Okay, they're both aqueous solutions. I dump them together to neutralize or try to neutralize it. And it says what's present in excess. Well, if you look at this, since it's 1-to-1 ratio, 1-to-1, and you have, it looks like you have more moles of sodium hydroxide. It looks like the NaOH is present in excess, and that would make it basic. So the solution is basic. And Mr. England and I just talked. I'm going to try and be setting up a lab, probably not next week because it's a short week, but the following week we're going to do what's called a titration. It's going to involve adding some acid and bases together to neutralize it, and an indicator, which if we were in the lab, we would use a fancy indicator, right? Phenolphthalein that turns pink. But since we're at home, we're going to be using our cabbage juice. So those of you who are in physical science, you'll remember that. But we're going to do a titration with our indicator to determine how concentrated an acid is. So that's coming up probably, I don't know, week 8. But I'll have some sign-up sheets because I want to get you guys lab supplies. So I'm coming up with a way to deliver lab supplies. It might involve going to Lewis and Clark or McBride for lunch. So stay tuned for that. With that, I'm going to stop the video. Hopefully you guys can find your answers. Again, ask your classmates for help. Um, Communicate with one another. Send Mr. England and I emails. And then big thing, submit what you have, especially if you could do that by Saturday. Turn in what you have so we can get your grades updated because we got to keep moving forward. So enjoy the weekend. I'll see you guys next week.